Assalamualaikum and hi everyone. My name is Muhammad Fikri bin Muhammad. My matrix number is 208257. So today I will give a little briefing about statics. Okay, so let's move on. Okay, so what are the topics that we will be discussed today? So first we have general principles. Second, we will talk about force, equilibrium of particles, and equilibrium of a rigid body. And lastly, we will talk about friction. Okay, so first we will talk about general principles. Okay, first we have length. Okay, so lengths are the one of the basic quantities that we will discuss today. Okay, so length is used to locate the position of a point in space, and then we describe the size of a physical system. So the SI units that we use is meter. Okay, so next we have time. Okay, so basically time is a succession of events, and the SI unit is seconds. And then we have mass. Mass is a measure of a quantity of matter that is used to compare the action of one body with the another. So SI units that we use to describe mass is a kilogram. So lastly, we have force. Okay, so force is considered as a push or pull exerted by one body on another. Okay, this interaction can occur when there is direct contact between the bodies. Okay, for example, a person pushing a trolley. Although the force can be occur through a distance when the bodies are separated. Okay, simple example, we have magnetic force and also gravitational force. Okay, although there is no direct contact, there is force that presence in that situation, and force also have magnitude, direction, and point of application. So next we will talk about idealizations. Okay, the purpose of idealizations is to simplify the application of theory by the mechanics engineering. Okay, so we have first particle. A particle has a mass but a size that can be neglected. Okay, so besides that we have a figure, okay, showing a particle. We have gas, solid, and liquid. Okay, so next we have rigid body. Rigid body can be described as a combination of a large numbers of particles, and all the particles remain at a fixed distance from one another. Okay, as we can see, solid are the one of the example of rigid body. Okay, so next we have concentrated force. Okay, a concentrated force represents the effect of a loading which is assumed to act at a point on a body. Okay, which means that in a body there is a point that the force focus on that point, so that's we call concentrated force. So next let's talk about Newton's three laws of motion. Okay, so we have three law. First law stated that a body at rest will remain at rest, and a body in motion will remain in motion unless it is acted upon by an external force. Okay, so we have second law. Second law stated that the force acting on an object is equal to the mass of that object times its acceleration. Okay, so the formula is F equal to ma, mass and acceleration. Next we have third law. Okay, it said that for every action there is an equal and opposite reaction. Okay, so there is a figure below that table. Okay, the first one is the first law. Okay, and the second one is the second law, and the third one is the example of the third law, the third Newton's law. Okay, there is force on A, on B, and then there is equal and opposite reaction. Okay, so next we have Newton's law of gravitational attraction. Okay, so any two particles or bodies have a mutual attractive force acting between them. Okay, for example, gravitational force, any particle located or near the surface of Earth experience it. Okay, so we experience it every day, gravitational force, and then this force we call weight. Okay, so there's a difference between mass and weight. Okay, and weight will be the only gravitational force considered in our study of mechanics. Okay, so next we have W equal to mg versus F equal to ma. Okay, so to calculate weight we don't use the acceleration but we use the gravitational force. Okay, and to calculate the force we use acceleration, so the difference is gravitational acceleration and acceleration. So we finish the first topic, which is general principles. So let's move on to the second topic, which is force. Okay, so what is force system. Okay, a force system is a collection of forces acting at specified locations. Okay, so there is many types of force, but today I will show you the concurrent force and also coplanar force. Okay, so the first one we have concurrent forces, which is there is two or more forces that intersect at a common point. Okay, if we look at the figure, the common point is the O. Okay, the point O. Okay, so next we have coplanar force. Coplanar force is a force that acting on a plane. Okay, so as we can see in the figure, all the forces acting on that plane. Okay, so next, so force vector. Okay, so first we will talk about scalar and vectors. Okay, so scalar is any positive or negative physical quantity that can be completely specified by its magnitude. For example, we have length, mass, and time. Okay, so next we have vector. Okay, a vector is any physical quantity that requires both a magnitude and a direction for its complete description. Okay, vectors that we will encounter in statics are force, position, and moment. Okay, so the major difference is scalar is only magnitude, and vector we have magnitude and also direction. So let's move on to the vector operations. Okay, so first operations we have multiplication and division of a vector by a scalar. Okay, so if a vector is multiplied by a positive scalar, its magnitude is increased by that amount, but multiplying by a negative scalar will also change the directional sense of the vector. Okay, as we can see in the figure, a, if we the vector a, if we multiply it by 2, it will be 2a. Okay, it will increase. Okay, but if a we multiply by a negative scalar, it will change the direction. Therefore we have negative a, and also we can have negative 0.5a. Okay, next operations we have vector addition. Okay, two vectors, when we add them, we must account for both their magnitudes and their directions. Okay, so to do this, we must use the parallelogram law of addition. Okay, so for example, vector a plus vector b will have vector r, which is the resultant. Okay, so how to do the parallelogram law? Okay, so the step is, first one we have to join the tails of the components at a point to make them concurrent. Okay, which is we know concurrent, they will intersect at a common point. Okay, so in the figure we can see a and b, we will join details. Okay, so from the head of b, draw a line parallel to a, while we have to also draw another line from the head of a that is parallel to b. Okay, so these two lines intersect at point p to form the adjacent sides of parallelogram. Okay, so after we join the tails, we must draw a line, okay, from the head of B and A, okay, until they intersect to the point P. Okay, so lastly, the diagonal of this parallelogram that extends to P forms R, okay, which then represent the resultant vector R equal to A plus B. Okay, so after we join the tail, we make the line from the head, okay, and then we join the common point to the point P. Okay, so there will be the R, okay, the resultant vector. Okay, so that's all. So beside parallelogram law, we can also use triangle rule. Okay, where vector B is added to vector A in a head to tail fashion. Okay, so for example, we have first steps is connect the head of A to the tail of B. Okay, and then after we connect the head and tail, the resultant R extend from the tail of A to the head of B. In a similar manner, R can also be obtained by adding A to B, which is R equal to A plus B. Okay, so by comparison, it is seen that vector addition is commutative. In other words, the vectors can be added in either order, which is we can do R equal to A plus B and also R equal to B plus A. Okay, so next we have special case. Okay, so if vector A and B are collinear, okay, so the resultant is straight line if the vector A and B collinear. Okay, so yeah, this is the triangle rule. So next we have vector subtraction. Okay, so the resultant of the difference between two vectors, which is a and b, of the same type may be expressed as r prime equal to a minus b or a plus minus b. Okay, why there is minus b? Okay, so as we can see at the parallelogram and also the triangle construction, we change the direction of b. Okay, we change the direction of b and then we find the resultant. Okay, so which is r prime. Okay, so after we do the calculation, we will get the a minus b. Okay, so a plus minus b equal to a minus b. Okay, so that's how we do the vector subtraction. Okay, so next we have vector addition of force. Okay, so just now we have learned about vector operation, but now we include the force. So we have vector addition of forces. Okay, so how to find the resultant force? We have two ways, which is law of sines and also law of cosines. But I will explain it later. But firstly, I want to talk about how we want to find the resultant force. Okay, we have parallelogram law and also the triangle rule. Okay, so for the parallelogram law, we can see that same as the vector, we connect the tail and then draw the line from the head, and then we get the point. Okay, the point, this point, and then we connect the common point to this point, we get the resultant force. Okay, so next for the triangle rule, we can connect the tail of F2 with the head of F1 to get the resultant force. Okay, so resultant force is equal to F1 plus F2. So as we can see, we can apply the parallelogram and also the triangle rule to find the resultant force. Okay, so next, law of sines and law of cosines. Okay, so we have sin A divided by A equal to sin B divided by B, and sin C divided by C. So what is the difference between the uppercase of A and the lowercase of A? So the uppercase is the uh, the so uppercase is the angle, okay, that uh, so the uppercase A is the angle that faces the uh, force A, the line that lowercase a. Okay, so same goes to B and C. So the uppercase B is the angle that facing the vector of V or the force of B. So that's the difference between uppercase and lowercase. So basically uppercase is the angle and the lowercase is the vector. Okay, so next we have law of cosines. Okay, so the law of cosines is equal to a squared equal to b squared plus c squared minus 2bc cos a. Okay, so just simple, we just we just insert the value of each lowercase a and also lowercase b, c and uppercase a, okay, to get the answer. So this is how we use the law of sines and law of cosines. Okay, so next we have the finding the component of forces. Okay, as we can see at this diagram, okay, at this diagram we have V and U, but how we want to find the component of forces to get the F, the resultant forces. So the component of forces is FV, which is this one, while we have also Fu, this one. Okay, so the component of forces is the forces that acting at the point. Okay, so after we find the component of forces, we can use triangle rule to get the value of resultant forces. Okay, so this is important when we solve the problem that involve the resultant force. Okay, so next we have addition of forces. So if more than two forces are to be added, successive application of the parallelogram can be carried out in order to obtain the resultant forces. So as we can see in the diagram, to find the Fr and also this F1 F2, so this 2 is the resultant force. Okay, but we have 3 force instead of 2, so we can always apply the parallelogram to find the resultant force. So we have to completely understand the parallelogram law and also the triangle rule. Okay, so now let's see the example. Okay, so we have this example involve resultant force. Okay, so the screw I, which is this diagram, is subjected to two forces, which is F1, which is 100 Newton, and F2, 150 Newton. So determine the magnitude and direction of the resultant force. Okay, so the only angle that given in this question is 10 degrees and also 15 degrees, which is from the F2 to the y-axis, and also the F1 to the x-axis. So after we get the diagram, first we must to draw the parallelogram to find the angle that important to our calculation, and also it is easy for us to convert it to triangle rule to apply the law of cosines of law of sines. Okay, so next after we get the angle and we draw the triangle, we can use the law of cosine. Okay, so I will explain to you the calculation. So as we know, the law of cosine formula is a squared plus b squared plus c squared minus 2bc equal to cos 2bc times cos a. Sorry. Okay, so here we have fr. Okay, fr, this example they square root. Okay, so fr squared equal to 100 Newton squared plus 115 squared minus 2 times 100 150 and cos 115. Why we use 115 is because the angle of 115 faces the resultant force. Okay, so actually this is the law of cosines. You can refer back on the previous explanation. So after we do the calculation, we get the resultant force, which is 213 Newton. Okay, so we will apply the law of sine to determine the direction. Okay, so 150 Newton divided by sin theta. Okay, and 212.6 Newton divided by 115. Okay, so as we can see, as we can see, the 115 Newton facing the theta, so that's why we use 115 Newton. Okay, so after you solve the problem, you will get the 39.8 degree. Okay, so 38.8 degree you must add with 15 degrees, so that's why we get 54.8. The 15 degree is we get from here, from the question, between the 100 Newton to the x-axis. Okay, so that's how we solve the resultant force problem. Okay, we will use the triangle rule and then law of sines and law of cosines. Okay, so before this we just talked about 2D vector. Okay, so now we will talk about 3D vectors. Okay, so first we have rectangular components of a vector. Okay, so a vector A, okay, as you can see in the figure, the blue arrow. Okay, a vector A may have 1, 2 or 3 rectangular components along the x, y and z coordinate. Okay, so the axis depending on how the vector is oriented relative to the axis. Okay, as you can see in the figure, we have A, okay, the vector A. So we have these rectangular components and also these rectangular components. Okay, so A equal to a prime plus az. Okay, a prime equal to az plus ay. Okay, combining this equation to eliminate a prime, a is represented by a equal to ax plus ay, a plus az. Okay, so you just need to focus on the final equation, which is to get the resultant force, which is a is equal to az plus ay and az. Okay, so in 3D vectors we will need to account for the x-axis, y-axis and also the x-axis. Okay, so next. Okay, so we have 3 ways to show the 3D vectors. Okay, so first way we have fx, fy and fz in terms of ijk. Okay, so as you can see in the example, for vector A we have ax I plus ayj and azk. So for fx we always use I, and for fy we always use j, and fz we use k. Okay, So these are the figure that we refer. Okay, so next we have the directional cosines. Okay, in terms of theta x, theta y, theta z, or alpha, beta, okay, and gamma. Okay, so we have cos alpha equal to ax divided by a. Okay, so ax is the force on the x-axis and ay is the force at y-axis, and same goes to z. Okay, so cos b equal to a y divided by a. Okay, and cos gamma, which is the theta z, equal to az divided by a. Okay, so a is the resultant force. Okay, so the last way we can also show the 3D vector using coordinate. Okay, in terms of coordinate form. Okay, so next we will talk about the addition of 3D vectors. Okay, so the resultant force equal to the total force. Okay, so how we want to calculate the total force is by we sum up all the forces that act on the x-axis, y-axis, and z-axis. Okay, so we must include all the forces acting on that axis. Okay, so total forces equal to total fxi plus total fyj plus total fzk. Okay, so example, express the force F shown in the figure, which is the 100 pound. Express the force. Okay, so let's express the force solution. So you just need to remember this formula. Okay, so I will not explain to you how to prove it in this presentation. So fz equal to f sin theta z, fx equal to f prime cos theta x, and fy equal to f prime sin theta y. Okay, so just insert the value. Okay, so our f is 100 pound sin theta, so the theta z is equal to 60 degree, which is this one, and theta x is theta x, and theta y is 45 degree. Okay, so just insert. So insert the value, we get 86.6 pound. To find f prime is we use f cos theta z. Okay, so our f is 100, our theta z is 60, so we get 50 pound. Okay, so after get the f prime, just insert it into the formula, and we get fx and fy. Okay, so fy has a direction defined by negative j. Why we get negative j is because as we can see, the force acted to the left side of the y-axis. As we know, the left side of y, we assume that it is negative. Okay, so the f equal to 35.4 I minus 35.4 j plus 86.6 k pound. Okay, so next I will explain to you one example of 3D vectors, addition of 3D vectors. Okay, so two forces act on the hook on shown in the figure, which is this figure. Specify the magnitude of F2 and its coordinate direction angle so that the resultant force Frx along the positive y-axis has a magnitude of what 800 Newton. Okay, so the formula that we will use in this question is this one. Okay, f1 cos alpha a cos theta beta 1. Okay, alpha 1, beta 1, and gamma 1. Okay, so this all are the angle. Okay, so as you can see, the alpha 1, the theta x, we have 45 degrees. Okay, and theta y we have 60 degrees, and also we have we have the theta z equal to 120 degrees. So how we want to uh, uh, determine the angle is by the question. So refer the figure. Okay, so just include so just insert the value of f and also the value of angle. Okay, so our f1 is 300 Newton. So after we insert, we get the magnitude of f1. Okay, so the formula of magnitude of f2 is this one. Okay, f2xi f2yj plus f2k. So before we find the f2, we must first determine the fr. Okay, so because we want to compare the equation, so fr equal to 800 Newton, okay, plus j. So how we get the 800J by the from the question, okay, because they want the resultant force is 800 Newton J. J is for y axis, okay. So Fr equal to F1 plus F2, since our Fr is 800J, okay. So once more I repeat, 800J we get from the question, okay. So equal to 212, so we just insert the F1 value, F1 magnitude plus the F2 magnitude, okay. So after we simplify, okay, so we simplify the equation, we get the I, J and K. So that's how we determine each uh, axis, okay. We only have y-axis because the question need the resultant force at y-axis, so that's why we put uh, zero value for the x-axis and z-axis, okay. So the magnitude of F2 is this one, okay. After we solve the value for each axis, we can get the magnitude, and also we can get the direction by using the uh, this formula, okay. Cos alpha equal to negative 212 we get from the magnitude, and 700 we get from the 700 is our total magnitude, okay. So yeah, this is the formula that we use, okay. I explained it before, which is the AZ divided by dA, okay. So that is the formula. So next we have the dot product, okay. So the dot product is the product of vector A and B written as A space dot space B, okay. It is defined as the product of the magnitude, okay, of A and B and the cosine of the angle between their tails, okay. So the vector A and B times the angle, okay. So the dot product is often referred to as the scalar product because it's the scalar product of vector, since the result is a scalar, not a vector. So these are some of law of operation. We have commutative law, which is A dot B equal to B dot A. Multiplication by a scalar A in bracket A dot B equal to A times A uppercase close bracket dot B, and also A dot in bracket A times B uppercase, okay. So we have also the distributive law, okay. So A times B plus D equal to A dot B plus A dot D, okay. So these are the law of operation, and also we have the Cartesian vector formula, okay. So A dot B equal to AXI plus AYJ plus AZK dot BXI plus BYJ and BZK. So after you solve the equation, simplify it, we can get this last equation, okay. So we finish on the topic of force. So let's move on to the equilibrium of a particle, new topics, okay. So first, a particle is said to be in equilibrium if it remains at rest if originally at rest, or has a constant velocity if originally in motion. So that is how we describe equilibrium of a particle. So to maintain the equilibrium, it is necessary to follow Newton's first law of motion, okay, which requires the resultant force that acting on a particle to be equal to zero, okay, which means that the total force equal to be zero. So that's why they can be in equilibrium, and also F equal to ma must be in zero. Okay, so next let's talk about the free body diagram. So there is 3 steps to draw the free body diagram, okay. So the first step, we have the draw the outline shape, and then we have show all forces, and third one is identify each forces, okay. So example, based on the figure, draw the free body diagram for the node at C if the sphere has a mass of 6 kg. So the node is here at the point C, okay. So firstly, draw the outline shape, which is the arrow of the forces in way, okay, sorry, first draw the outline shape, which is the arrow that describe the way of the force, and then show all forces, okay. As you can see in this answer, okay, we have phi CBA, which is the force of chord CBA acting on a node, okay. The C BA, this one, and then we have the FCD, which is the force of spring that acted on the knot, and lastly we have the force of chord CE, which is the this one, okay, that this the weight. Okay, so that's how we draw the free body diagram. First, draw the outline shape, show all forces, and then identify each forces. Okay, so if you have the angle, include also the angle. Okay, so basically this diagram show, okay, where the force go. Okay, so now calculation example. Okay, so the question is find the tension of the cable of BA, okay, this one, and BC, this one, if the weight of cylinder D is 60 kg. Okay, so first we need to state the equilibrium equation, which is the total Fx equal to 0, and also total Fy equal to 0. Okay, sorry, before that you need to draw the free body diagram. As you can see, the tension of C is headed toward the upper right direction, and we have tension A, so the direction you must follow the figure, and also the angle also we need to refer to the figure. Okay, so TBD is the weight of the cylinder, which is 60 kg times G, which is W equal to mg. Okay, so that's how we get the weight. Okay, so after you stated the equilibrium equation, after that you must see all you must sum up all the forces that acted on that axis. Okay, so first we have TC cos 45 minus 4 over 4 TA. Okay, this is for the x axis, okay, equal to 0. Then we have y axis. Sorry, back to the x axis. Why we get negative is because of the tension A is left side of z axis. Okay, so next we have Fy. TC sin 45 plus 3 over 5 TA minus 60 times 9.81. Why it is negative? Because it is directed towards downward, okay, which is the negative side of y-axis. So after you compare this equation, you can get one new equation. Okay, sorry, not compare the equation, but we use the first equation, the x-axis equation. So after that you just insert the value of TA and solve for TC. Okay, so after you solve for TC, you can solve for TA. So this is basic mathematics principle. Okay, so the crucial part is where you listed all the forces that acted on the axis. Okay, so that's how you solve this problem. So next topic, equilibrium of a rigid body. So condition for rigid body equilibrium is this body is subjected to an external force and couple moment of system. Okay, so the internal force caused by the interaction between particles within the body are not shown because of why these forces occur in equal but opposite collinear pairs, and hence will cancel out. Okay, so this is consequences of Newton's third law. Okay, so as you can see in the figure, the forces all the forces and all the moment. So to be in equilibrium, Fr equal to 0 and total moment is equal to 0. Okay, so in equilibrium of a rigid body, we have two types, which is the 2 dimensions and also the 3 dimensions. Okay, so for 2 dimension is force system acting on the rigid body lies in or may be projected on a single plane. Okay, a single plane, and any couple moments acting on the body are directed perpendicular to this plane. Okay, so next 3 dimensions. Okay, so in 3 dimensions, directive forces and couple moments acting at various types of supports and connection. Okay, so I will explain it further. So let's see 2 dimensions support reaction. So what is support reaction? A support prevents the translation of a body in a given direction by exerting a force on the body in opposite direction, and also a support prevents the rotation of a body in a given direction by exerting couple moment on the body in opposite direction. Okay, so as we can see, we have some example. Okay, first we have a member pin connected to a cola smooth rod. Okay, so we have one unknown. The reaction is a force which act perpendicular to the root. Okay, so this is two-dimension equilibrium body. Then we have fixed support. Okay, so we have three unknown. The reactions are the couple moment and the force, and the two force, sorry, three unknowns. The reactions are the couple moment and the two forces components, or the couple moment and the magnitude and direction of theta of the resultant force. Okay, so this is the force acting on this body. Okay, so this is support reaction. So next we have equation of equilibrium. Okay, so as we know, to be in equilibrium state, total Fx, total Fy must equal to 0, and also the moment equal to 0. Okay, alternatively we can also write as total Fx equal to 0, total moment A equal to 0, and total moment B is 0. So beside that we have figure. So this is the figure that we refer. Okay, now let's move on to the three dimensions. Okay, so just now we learned about support reactions for two dimension. So support reaction for three dimension is a force is developed by a support that restrict the translation of its attached member, and also a couple moment is developed when rotation of the attached member is prevented. Okay, for example, you have ball and socket. Okay, for ball and socket, we have three unknowns, and the reaction are the three rectangular forces. Okay, component. Okay, we can see this is the force uh, acted on this ball and socket, and the second example is a fixed support. Okay, so in fixed support we have six unknown. Okay, the reaction are three forces and three couple moment component. Okay, so these are the example for support reaction in three dimension. So next, equations of equilibrium in three dimension. So we have vector equations of equilibrium, still the same. Total force must equal to 0 and total momentum must be in 0. Okay, so next we have scalar equations of equilibrium. Okay, so total F, we have Fxy plus total Fyj and total Fz K. Okay, so this is the force acted on x axis, y axis, and z axis, and also same goes to the moment, total moment equal to 0. Okay, so since the I, j, k components are independent from one another, the above equations are satisfied provided which is total fx equal to 0, total fy equal to 0, and total fz equal to 0. Same goes to the momentum. So in equilibrium, anything equations is must equal to 0 because there is no motion. There is motion, but there is no there is a constant. Okay, the Newton's third law. Okay, now let's move on to the last topic for the day. Okay, which is friction. So what is friction? Okay, so friction is a force between two forces that are sliding. Okay, sliding or try to slide across each other. Okay, which will produce friction. Okay, as we slide our hand, this is a simple example of friction. Okay, so characteristic of dry friction, because in this mechanics engineering or statics we will focus more on dry friction. Okay, so dry friction, which is also known as column friction, occurs between the contacting surface of body when there is no lubricating fluid. Okay, simple. If dry, there is no fluid. Simple to remember. So now we will talk about the type of dry friction. Okay, so the first type of dry friction is impending motion. Okay, so when the surface of contact are rather slippery, the frictional force F may not be great enough to balance P, and consequently the block will tend to slip. Okay, refer this figure. Okay, so the P is this one and the force is a frictional force. Okay, so as P is slowly increased, F correspondingly increase until it attains of certain maximum value, Fs, called the limiting static frictional force. Okay, so when this value is reached, the block is in unstable equilibrium. Okay, so any further increase in P will cause the block to move. Okay, so this is the formula, which is Fs equal to friction coefficient times of times n. Okay, so if the maximum value of the maximum value of limiting static frictional force is achieved, if we increase the force, the block will move or will move. So next we have motion, okay, the second type of dry friction. If the magnitude of P acting on the block is increased so that it becomes slightly greater than Fs, the frictional force at the contacting surface will drop to a smaller value, Fk, called the kinetic frictional force. So the block will begin to slide with increasing speed. So after the block move, if we increase more the force P, so the block will move in a will move faster lah because of the increasing speed. So the formula of motion is this one, Fk equal to mk times n. Okay, so next, what are the problems involving to dry friction? So today I will talk about the common problem. Okay, first, the common problem is no apparent impending motion. Okay, so the characteristic of the problem is number of unknowns to be equal to the number of available equilibrium equations. And also, after we get the frictional force solution, sure they satisfy this inequality. So after we get the frictional force, we must make sure that the force satisfy this inequality. Okay, so that is the first problem. Secondly, we have impending motion at all points of contact. Okay, so the total number of unknowns will equal to the total number of available equilibrium equations plus the total number of available frictional equation. Okay, sorry, this is equation. So next, when the motion is impending at the points of contact, then Fs, then this is the formula that we use. And lastly, whereas if the body is sleeping, then the Fk is equal to mu k times n. Okay, so these are the three equations that we will use based on this situation. Okay, so now the last common problem involving dry friction is impending motion at some point of contact. So here the number of unknown will be less than the number of available equilibrium equation plus the number of available frictional equation or the conditional equation for tipping. So as a result, several possibilities for motion or impending motion will exist, and the problem will involve determination of kind of motion will actually occur. So in this problem we will determine the kind of motion. Okay, so now let's move on to the example of friction. Okay, this one example. So a crate has a mass 20 kg. If a force of P equal to 80 Newton is applied to the crate, determine if it remains in equilibrium. Okay, the coefficient static is ms 0.3, so we must determine is it equilibrium or not after the pressure is or the force is applied. So the solution is, first you must draw the free body diagram. Okay, so this is the free body diagram, and then you must listed all the equilibrium equation. So after then you can determine each force. Okay, in x-axis we have 80, which is the pressure, cos 30 degree. Okay, we can get this 30 degree minus F. Okay, so the Fy on the y-axis we have firstly negative 80. Okay, negative 80 sin 30 degree times Newton plus NC. Okay, because NC is y-axis, located at y-axis, minus 196.2 Newton because it is also located at y-axis, and we have the total moment. So this is the formula to the for the total moment. So after we compare the equation and we solve it, we can get the F equal to 69.3 Newton and C 236.2 Newton, and X, which is the this one X, we get negative 0.00908 meter equal to negative 9.08 millimeter. Okay, so the X. Okay, so since the X is negative, it indicates the resultant normal force acts slightly to the left of the crate center line. Okay, so no tipping will occur since the X below 0.5 meter. Okay, because after we calculate, the X is small. Okay, so also the maximum frictional force which can be developed at the surface of contact is F max mu s and c equal to 70.9 Newton. So since the force is greater than 66.93, so the crate will not slip, although it is very close to doing so. Okay, so that's how we determine the F and C and X, and we decide it is equilibrium, it will stay in equilibrium or not. Okay, so now that's a long briefing of statics. I hope you understand and enjoy my video. So that's all from me. Thank you.